Okay, today we're going to work a stoichiometry problem. We're going to start with a simple problem. All we're going to do is, if we're given that 15 grams of iron are produced by this reaction, we want to start out looking at how much aluminum and iron 3 oxide is required to produce that amount of iron. And then we're also going to answer another question, and that'll be how much aluminum oxide could be produced by this reaction also. Okay, so remember stoichiometry, what we're talking about is if you have a measured amount of one substance in a chemical reaction, use then mole-to-mole ratio, use the balanced equation, use atomic masses and molar masses from the periodic table, and find out about another measured amount. So we like to talk about this in terms of the mole train. But before we get to that, the first thing you always have to do in a stoichiometry problem is make sure that the equation is balanced. Okay, so we look here, we start with 2 irons on this side. We only have 1 on this side, so we have to take that times 2. Look at the oxygens, there's 3 here. We've got 3. We've got 1 aluminum. Over here we have 2. So now this is a balanced equation. Now it gives us the ratio of iron 3 oxide to aluminum, or to iron, or to aluminum oxide. And you can connect the dots with any of those other compounds or elements in there to give you what's called the mole-to-mole ratio. Right, now typically we'd have to go through and do the calculations for these compounds, but to speed up the process here, I've already calculated those and put them on the board. Right, so what we do is we start with our given amount, which in this case is 15 grams of iron. Okay, now what we will do is figure out how much iron 3 oxide we need to produce 15 grams of iron. All right, your first step is to go from grams to mole. Okay, in order for labels to cancel out, we must have grams of iron on the bottom. We want to know about moles, so that goes on the top. Okay, according to the periodic table, 1 mole of iron always has a mass of 55.845 grams. Okay, so now we're in moles of iron. We want to get to iron 3 oxide. The balanced equation doesn't give us a ratio of grams to one another. What it gives us is a ratio of moles. Okay, so now we want to go from moles of iron to moles of iron 3 oxide. Okay, the ratio is given to me by the coefficients, the numbers written in front. Okay, so this says there's 1 iron 3 oxide for every 2 irons. Okay, then our final step is to go to grams of iron 3 oxide. So for it to cancel out, you put moles of iron 3 oxide on the bottom. Okay, and you put its molar mass on top, and that's 159.688 grams. Okay, so the math that we're being asked to do here is take 15 divided by 55.845, also divided by 2, and then times 159.688 grams. We can look at the answer for that here in a minute. Okay, the second part of this question was knowing that you've made 15 grams of iron. That's what was given. Okay, how many grams of aluminum are needed to produce that amount? First step looks exactly the same. We convert to moles of iron. Okay, now for the second step, the mole-to-mole ratio we use now is from iron to aluminum. And that says 2 moles of aluminum will produce 2 moles of iron. Okay. Now to convert to grams, we use the atomic weight of aluminum, 26.9818. Okay, That's in grams though. It's the mass of 1 mole of aluminum. Okay, so now what we look at is 15 divided by 55.845. We could do times 2 divided by 2, but those cancel out, so you could just ignore that. And so it looks like 15 divided by 55.845 times 26.9815. Okay? Now for the final step, it says, well, how much aluminum oxide does that make? Okay? The mole-to-mole ratio, okay, the stoichiometric relationship that you have here does not change. So what you can do is use this amount of iron to figure out how much aluminum oxide should be made with it. First step looks the same. Okay, second step, now what we want to do is use the mole-to-mole ratio to aluminum oxide, and that says 1 mole of Al2O3 for every 2 moles of Fe. Again, remember that's coming from the coefficients. Okay, and the final step, convert it to grams. The molar mass of aluminum oxide is 101.961 grams for 1 mole of aluminum. Okay, so what I want you to do is really quick, get in there and calculate these. Remember, we get our sig figs from our measurement or our given amount, not from any of these definitions, these exact numbers. Okay, so all your answers should be to 3 sig figs. Go ahead and do that real quick, pause the video, and we will check the answers here in a second. Okay, now that you've had a chance to do this, let's check our answers. We should get 21.4 grams of Iron III Oxide are needed to produce 15 grams of iron. That would be accompanied by 7.25 grams of aluminum. Okay. Also produced by this reaction would be 13.7 grams of, oh, bad label, Al2O3. Okay, so the way we check this then, just for correctness, is all this established was if we were in a perfect relationship here, no excess. So these are the reactants. Okay, that adds up to 28, if you use sig figs, 28.7 grams. Okay, well here's one of our products, and the other one was the given, and that's 15 grams of iron. You add that together, 28.7 grams of product. That's how we check our answer. They're the same on the left side of the reaction, the right side of the reaction. So there is the first stoichiometry problem that we'll have to do in this class.